ISPs. Larger ISPs connect to the backbones of the Internet. An Internet backbone is a network made up of high-speed and high-capacity lines. Backbones are like major highways for information. They carry an enormous amount of traffic. As information travels along an Internet backbone, it might pass through servers and other devices on each network. These devices help the information reach the correct destination. Every device on the Internet has a unique number. This number is called an Internet Protocol, IP address. IP addresses are long strings of numbers. They can be hard to remember, so IP addresses are often matched up with domain names. A domain name is made up of letters. It is part of a Uniform Resource Locator, URL, or website address. When a person types a domain name, a request goes to a local domain name server, DNS. The DNS looks up the IP address that matches the domain name. If the DNS does not know the IP address that matches the domain name, it can send requests to other servers to find the address. Then the DNS connects the person's computer to that address. A router is a special kind of server. Routers direct the flow of information. They send each file toward its destination. They can even send files across oceans. Undersea cables connect hubs on each continent. Chapter 3. It's all in the protocols. Computers use protocols to send information from one device to another. Transmission Control Protocol, TCP, breaks down the information into smaller pieces. Then Internet Protocol, IP, tells those pieces where to go. These protocols are often referred to together as TCP/IP. When a person sends a file using the Internet, TCP breaks down the file into small chunks called packets. Packets are tiny. Each one contains fewer than 1,500 characters. TCP may break one file into thousands or millions of packets. An email message containing 3,500 bits of data might be split up into 4 packets. Each packet has a header. The header has information about how to put the file back together. Each packet also contains the sender's IP address and the receiver's IP address. IP uses this information to tell the packet where it needs to go. Then routers help the packet get to its destination. Routers tell the packet how to reach the receiver's IP address. They find the most efficient path for each packet. Routers often work together to send a packet to its destination. The Internet is made up of many interconnected devices and wires. Sometimes one of them is busy or broken. Routers keep track of all the different ways they could send each packet to its destination. That way, if one of the devices or wires is busy or broken, routers can find a way to send the packets around the problem. When the packets get to their destination, TCP checks to make sure that all the packets from the file have arrived. If any packets are missing, TCP sends a message back to the original computer. It asks the computer to resend the packets. Once all the packets reach their destination, TCP uses the information in the packet headers to put the file back together. Critical thinking. Why is it important for TCP/IP to check that all of the packets arrive at their destination? How it works. HTTP and HTML. The World Wide Web is made up of many web pages. For a person to visit a web page, his or her computer must ask another computer for information. A protocol known as Hypertext Transfer Protocol, HTTP, makes this possible. HTTP is the set of rules that browsers and servers follow when asking for and receiving web documents. When a person types a URL into a web browser, the browser sends a message